On the 14th of May 2009, an Ariane 5 was launched from Kourou in French Guiana. On board were two of the most ambitious scientific projects ever attempted by ESA. The Planck satellite, designed to measure so-called fossil radiation emitted during the formation of our universe, and the Herschel Space Telescope, which observes in the far infrared, investigating objects among the coldest in the cosmos. Herschel then immediately commenced its commissioning activities while en route to its operational orbit around the second Lagrange point, 1.5 million kilometers from Earth. There, the gravitational pull of the Earth and the Sun balance each other out, allowing Herschel to have its instruments permanently pointed away from the Sun and to explore further into the far infrared than any previous mission. Herschel will study otherwise invisible dusty and cold regions of the cosmos, both near and far. For the last 2 years, Herschel has been observing the universe from this position, taking advantage of its 3.5 meters diameter telescope, the largest ever sent into space, and its 3 science instruments. The result, a treasure of information to astronomers, images and spectra of a huge variety of objects near and far.
The idea was to open up the last remaining part of the spectrum between the infrared and the radio, which you cannot see from the ground because of the atmosphere.
A celestial body looks different depending on the wavelength of the radiation observed, and Herschel's instruments make it possible for a more complete picture to be seen. A good example is the Andromeda galaxy, about 2 million light-years away.
In the optical image, basically you see light from stars. So you see the stars which are there in the galaxy now. When you go into the infrared, you see emission from dark, big clouds of gas and dust in Andromeda. And in fact, this is the parts of the galaxy where stars will form in the future. In the X-rays, you see stars which lived and died. So the 3 pictures are very complementary.
Herschel's observations are archived at the European Space Astronomy Centre, ESAC, in Spain. The data are received via the most modern satellite tracking station in the world, ESA Cebreros, some 70 kilometres west of Madrid, and a similar one in New Norcia, Australia. Their 35-metre diameter antennas pick up signals from Herschel, which can be up to 1.8 million kilometres away in space. In the first year and a half of operations, tens of terabytes of data have been ingested and stored in the archives. The data from the observations, requested by astronomers from all over the world by competitive selection, are processed into standard products, images and spectra, and made available over the internet by the Herschel Science Archive at ESAC. The improvement in the quality of the information that Herschel gathers compared to other infrared space telescopes has opened up new horizons for many areas in astronomy, from cosmology to astrochemistry.
We can see star formation going on 10 billion years ago in the early universe. And we can also observe in our own galaxy the chemistry in these clouds from which stars form.
Herschel has exceeded all expectations. It has produced the most fabulous scientific results. It's producing some images of a quality that we just couldn't believe. And such a complicated machine with so many parts that could go wrong. Everything is working almost perfectly, which is just unbelievable out there in space. We are going to learn so many things, and people are going to be working with Herschel data maybe for 20 years after the mission actually ends.
Herschel will continue to operate until sometime early 2013, ample time for ESA's infrared space telescope to answer many of the questions astronomers have been posing for centuries.